Hello everyone, welcome to Mariner's Point. Today in this video, we are going to discuss MU Class 4 Electrical Written Numerical Questions you can see on the screen. A coil of resistance 10 ohm and inductance 0.1 Henry is connected in series with a capacitor of capacitance 150 across a 200 volt 50 hertz supply. Now we have to calculate inductive reactance, capacitive reactance, circuit impedance, and the circuit current. We have to calculate the circuit current, the circuit power factor, the voltage drop across the coil, the voltage drop across the capacitor. All these we have to find in this question. Now, what are the data we have given? We can see in this photo, you can see all are in series, resistance, capacitor, inductance, all value is given. What are the data given? First, we will write. You can see on the screen resistance is given, inductance value is given, capacitance is given, supply voltage is given, and frequency is given. Okay. Now, first we will calculate inductive reactance. Formula for inductive reactance is equal to omega L. Okay. Value of omega is 2 pi frequency into L. Value of 2 we already know, pi value know, frequency is given 50 hertz and L is given 0.1 Henry. So in this value when we will put, we will get value of inductive reactance XL is equal to 31.42 ohm. Next we have to calculate capacitive reactance, which is equal to XC. It is represented by XC. And formula for this is 1 omega C. Value of omega we already know, then formula will become this one. And simply we have to put the value of frequency and capacitance, and we will get the answer for capacitive reactance is 21.22 ohm. Next, circuit impedance. Circuit impedance represented by Z. For a series RLC circuit, you have to remember this formula. For a series RLC circuit, you should know this formula. Z is equal to under root R square plus XL minus XC का square. Okay. So we have already calculated value of XL and XC, and resistance value is given. So value of circuit impedance is 14.28 ohm. Okay. Now circuit current we can calculate. For this, simply we know that V is equal to IR. R is resistance. Here we can apply this formula. I is equal to V by R. Resistance is total resistance. Each impedance we already calculated. So when we apply, voltage is given 200 and Z is 14.28, then circuit current will be this one. Okay. Next we have to calculate circuit power factor. Power factor simply this is Z R. Okay. So you can apply this formula here. Cos phi is equal to R by Z. Now power factor lagging and leading. How can you know that? For this you have to remember, if XL greater than XC, circuit is inductive and in lagging. Okay, you have to remember this. How do you know it is lagging or leading? Value of XL and XC denotes you represent you. It will be lagging or leading. Okay. Next, voltage drop across the coil R plus L. So resistance plus inductive we have to calculate. So we will first calculate total resistance for resistance and inductance. For this, simply formula you can calculate by this one. Here we have removed XC. We have to only calculate inductive, not capacitive. We have to not include, only we have to include resistance and inductive. So you can use this formula and the value of Z across coil, that means R plus L, you will get, and simply you will apply the formula V is equal to IR, and you will get this answer, voltage drop across the coil. If you have to calculate voltage drop across the capacitor, so we will know the resistance across the capacitor by using formula XC omega C. Value of omega we already know. So XC we already calculated. Okay. Now, so voltage drop across the capacitor we also find by using this formula. Okay. So all that value we already calculated. This question is very simple.